in this example, we're talking about the classical approach to probability. And I want to remind you of a little bit of notation. We would read this as P of A. In other words, probability of A. Capital P representing probability, and A is going to be an event. And so this means probability of A. And probability of A is equal to the number of ways event A can occur divided by the number of different simple events in the procedure in question. Okay, now let's talk about this particular example. Consider the procedure of flipping a coin 3 times. What is the probability of the coin landing on heads exactly twice? So we're not talking about 2 or more, we're talking about exactly twice. In other words, it could land heads, heads, tails, that would be exactly twice, or it could be tails, heads, heads, that would be exactly twice. Okay, so our event A is the event of the coin landing on heads exactly twice. And to do this problem with a classical approach, we're going to write out the complete sample space of this event. So let's look at this. We're going to flip a coin 3 times. Remember, there's 3 coin flips. And now think about this. We could get heads on the first flip, heads on the second flip, and then tails on the third flip. That's one way this procedure could turn out. That's one simple event, so to speak. But think about this. We may not always get what we're looking for. We may not always get exactly 2 heads. We could get heads, heads, heads. That's another possibility. And in fact, we have to write out all the possibilities. So let's think about this logically. We could get heads, heads, tails, or heads, 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 or we could get, what's another possibility? Heads, tails, heads. Or there's yet another possibility, heads and then tails, tails. Now I think I covered all the possibilities of what could happen if I get heads on the first flip. But what if I got tails on the first flip? I think there's going to be 4 more possibilities that could happen if I got tails on the first flip. Let's see. If I get tails, I could get heads on the second, tails on the third, or I could get heads and heads, or I could get tails and then, let me see what I'm missing. I could get tails and heads, that's yet another possibility, or I could get tails on the first, tails on the second, tails on the third. All right, so I listed the 8 different possibilities that could happen if I flip a coin 3 times. And again, order is implied in the problem. It doesn't specifically mention the word order in the problem, but order is implied because we're talking about a first flip, a second flip, and a third flip. So when I think about this methodically and very slowly, I see that there's actually 8 different simple events, 8 different ways this procedure could turn out. Okay, and with the classical approach, we have to look at this now and think, how many ways are there to get exactly 2 heads? Now let's look. This first thing I listed, heads, heads, tails, that's exactly 2 heads. All right, where else do I have exactly 2 heads? Okay, this would be heads, heads, heads. This would be heads, tails, heads. That would be exactly 2 heads. Okay, this would be heads, tails, tails. Tails, heads, tails. Okay, this one right here, tails, heads, heads. Exactly 2 heads. Okay, then tails, tails, heads, and then tails, tails, tails. So how many ways of getting exactly 2 heads? There would be 1, 2, 3 ways of getting exactly 2 heads. So the probability would be 3 divided by, and remember what these represent. I listed 8 different ways of flipping the coin 3 times, so there's 8 simple events. So the probability of getting exactly 2 heads is going to be 3 over 8. And that is the final answer. The probability of flipping a coin 3 times and getting exactly 2 heads is 3 over 8.